Kia ora and g'day everyone. Thank you all for being here today. Our discussion panel is a bit new for our MARKHAM webinars, but we're keen to get into the science and practical challenges of adding life to ageing structures. Before we dive in, we'll introduce ourselves. I'm Venus Flores, part of the administration team here at MARKHAM in Napier. We have Martin Prestige from Napier also. Doug Hamlin is from Napier, but he's coming through from Nelson today. And we have Brad Fletcher beaming in from Sydney. Martin, would you like to say a bit about yourself, and Doug and Brad follow up?
Thank you, Venus. Yes, I'm Martin Prestige. Been with the company for a few years now. Worked across the construction sector and the concrete durability sector with civil concrete repair companies, asset owners, and yeah, so that's me. Doug, good to see you down in Nelson.
Yeah, likewise, Martin. Thanks for that. Yeah, briefly, I've been working with MARKHAM for just on 10 years. Started off in a project management role and now work in design and specification and civil structures. So yeah, that's across Australia and New Zealand. Over to you, Brad.
Yeah, thanks, Doug. Good to see everybody. Thanks for joining us. I'm Brad Fletcher from the Sydney office. So I work mainly in the Australian projects. So I'm work in the construction and also the civil remediation area. So I work a lot with engineers and architects, and also, of course, end users as well, looking at ways to improve the design life and life of their structures. That's me. Thanks.
Great, okay. The discussion is going to take about 20 minutes, and then the guys will respond to your live questions afterwards. There is a little Q&A button just below on the floating toolbar, so if you have any questions at any time, you can just write them in there and I'll ask them afterwards. So let's get into it. Martin, how important do you think it is to extend concrete structures' service life in today's world?
Thank you, Venus. Yeah, very important. We're seeing a lot of premature deterioration of concrete structures, whether that's because they're being built to budgets, maybe in environments that we've traditionally not been building in. But what we're seeing is extensive repairs being required before they meet the end of their design life. So cycles of breakout repairs, inspections, kicking in before they're intended. And the other side to that is a lot of ageing structures and the infrastructure are being required to keep going a lot longer than the existing design life with the growing population, limited budgets. It's no longer feasible to knock down every structure when it gets to the end of its design life. So extending the design life of structures and then increasing the design life of modern structures is very important as well. You've probably got a few comments on that, have you, Brad?
Yeah, thanks, Martin. Yeah, some great points there. Obviously, as you say, it is very important. And the flip side of structures being used for longer or lasting longer if possible is obviously those cost savings for everybody, really. You've got your taxpayers obviously bear the brunt of the bill to build new structures. So it's definitely a very important part of what we do and what a lot of people out there doing, making those structures last longer and stronger.
Yeah, that sounds like quite a challenge. What are the underlying reasons for that, Doug?
Yeah, no, that's yeah, I think Brad and Marty have outlined the problem there quite well. I guess looking at some of the concrete itself and some of the science there, concrete's really got one major flaw with it, and that's the fact that it lets moisture, not only lets moisture into it, but it also lets it move around. And this, if it's just normal concrete, is fine, but as soon as you start thinking about the reinforcing steel, and then you start thinking about it might be in a marine environment with chlorides or salts, or it could be a structure under acid attack. This moisture actually takes these contaminants through the concrete and starts breaking the concrete down, but worse, it gets through to the reinforcing steel and starts that corrosion process. So yeah, I guess if you put it down to one factor, it would be the moisture movement in concrete. Leads to a lot of these structures not meeting their service life, or breaking down once they get well on in their service life. And just lastly, before I hand back, the cycle of deterioration in concrete it accelerates very fast. So if you think about it in terms of a graph, it's an exponential rate of deterioration. It's not linear or flat by any means. So yeah, the costs and associated with repair escalate very quickly over time. I hope that helps.
Okay. So if you're seeing these challenges frequently, what do we have to offer? What answers do we have to offer? Sorry.
I thought we could have a look at some case studies. Probably the easiest way to explain which way we can help extend the life of these structures. So we get a lot of acid owners. This is a typical one that we did down in Adelaide. So you get the asset owner not spending any money through the life of his project, realise that they've got a structure in the middle of the CBD that they actually get a good income off, and then suddenly need to increase its design life. So this was one of your projects, Brad, one of your favourite cities down there in Adelaide.
Yeah, 100%. The beautiful city, the city of churches, I think they call it. So yeah, that's right. The Rundle Street car park right in the middle of Adelaide. We got involved with it quite early on with the engineers that were looking at this one. So as Martin said, so reaching the end of design life, they were looking at what sort of condition was, and also what could be done to improve its condition. And the end goal obviously was to extend the life of the structure. So they had a few issues with the structure, which was your typical issues, I suppose, on this sort of structure. So they had some contaminants that brought in by the cars, so they had carbonation issues. They also had some corrosion issues of the steel. So in areas, the steel had actually rusted and broken out. So there was concrete cracked and also breaking away. So there was a bit of a two-part system for this. They obviously wanted to repair the broken concrete and then make sure that the structure would last. So we came in with one of our Acron hydrogel sealing products, an internal treatment. So once the repairs were done to the structure, we came in and we spray applied our treatment to it. This was for two purposes. The first being to stop any further contaminants getting into the concrete, and then also any contaminants that were in the concrete, locking them up, stopping them from causing more damage. This one was a fairly interesting project, actually, right smack bang in the middle of the COVID times. So part of our system, or part of our services, we inspect the structures ourselves. So trying to get down there was fairly difficult, but we managed it. And then, as well as with the application, we go down there and make sure it's done up to scratch, of course. Doug, do you want to run through on why the hydrogel is a good fit for these sort of projects and how it works?
Yeah, sure thing. So yeah, as you can see on the slide there, what you can see what I was talking about with untreated concrete. See the moisture ingress in there. You can imagine that's moving around. In short, what we're doing with hydrogels is it's a colloidal silica base that reacts with the alkalis in the concrete pores. So these are naturally found there in concrete. And we form a hydrogel, so that reacts, forms a hydrogel and stops that moisture moving through the concrete, and or stops it actually ingressing the concrete, but then stops it moving around inside the concrete as well. So bringing this back to the Rundle Street project here, this was very important because it meant that further contamination, such as carbonation or chlorides, couldn't actually get into the concrete, via the moisture. and also that those contaminants, if they were already in there, were bound up in the hydrogel. Now, sometimes on these projects, it happened on this one, you've got a lot of there's a lot of oils and oil spills from the years of use in the car park. And when they were installing it, the oil actually purged out of the concrete. So if you think about like the hydrogels kind of displacing those contaminants, things like that. So we're actually not only protecting the concrete, but we're removing some of those nasty contaminants out of the concrete as well. So Martin, you saw that in real life. Do you want to tell us a bit about that?
Yeah, so as you say, Doug, fully prepared surface, pressure washed and detergent cleaned back as much, everything moved off the surface as we could. Fresh clean concrete, and we put the hydrogel on, and within hours you could wipe oil off the surface that has been purged out of the pores. So, especially in the centre of the car parking bays where they've had a lot of oil drips, becoming mini Texas oil wells. Yeah, it's good.
So it's all about immobilising the moisture and arresting the deterioration. Do you have any other case studies you wanted to show us?
Yeah, we sure do. This one's on the other side of the world, island of Jersey in the English Channel. Obviously very coastal, as the whole island is, so high salt content, a lot of chlorides, airborne chlorides, were contributing to early deterioration of this car park. Our UK team went over there and sprayed it out once again with the hydrogels, and were able to arrest the corrosion. So, as Doug touched on early on in the presentation, removing moisture, you're rendering the chlorides useless in the corrosion process. So moisture and chlorides obviously accelerated corrosion. Waterproof the structure with the hydrogels and extend the life, arrest the corrosion. That was all carried out while it was operational too. Very environmentally friendly product and no major downtime, which is a major plus for these projects. While we're on the marine theme, I think we've got another project here of Brad's.
Yeah, that's right. So this is a wharf in Geraldton over in Western Australia. So once again, this is a very harsh environment. So obviously got your airborne chlorides from the sea level right there. Then you've got heavy loads, those sort of things on the wharf. So we got involved in this one once again early on. They had high levels of chloride inside the concrete, which resulted in them having to do some breakout repairs. And then we got involved with the engineers. We're looking for a solution to reduce the permeability of the deck and soffits. So the reason they wanted to reduce the permeability was, as Doug's mentioned, that's the permeability or the voids and porosities in the concrete is where those contaminations are coming into the concrete. So they wanted to stop any further contamination getting into this wharf. Now, so one of our Aquan hydrogel treatments, we put this forward as a solution for this. One of the interesting things on this project was they did testing on site to confirm that the product was working. So to do this, they took cores out of the wharf, the top deck and the soffit. So they cored it out before treatment, tested how permeable it was, put the cores back in and we sprayed the deck out, and then I pulled the cores back out and retested to check the permeability. What we were seeing in this one as an average was a 70% reduction in permeability, which is obviously a great result for the client. Martin, can you add anything on that? You were also involved in this one.
Yeah, it was an interesting project. So the asset owner did a lot of testing throughout the application, as you mentioned, Brad, just wanting to be assured of the efficacy of the product. So every work bay was tested. One of the interesting things, they pulled the core out, pressure tested the treated surface, but they also flipped the core just off their own back and treated the internal side of the core for permeability, and what they found is they get this very similar result, treated side and then 200 mils in to the untreated side, which was a great testament to the penetration abilities of the hydrogel. The only way we could have waterproofed the full thickness of the core was through the surface, so it was good to see. It's great. Doug, did you reviewed that testing? Did you have any comments on that one?
No, I think you've covered it in the main there, but yeah, it was very extensive. They required, every 20 metres down the wharf to have the test carried out, and yeah, that was at least a 70% reduction. It's good, yeah, like you say, to be able to show that performance on site, and then also monitor that performance over the long term as well. So yeah, it provides a meaningful treatment, meaningful warranty. But yeah, over to you, Venus.
Cool. Well, the time and downtime savings must be a huge value to the asset owners. I just want to quickly jump in and just remind you guys to pop your questions in the Q&A button down there. I have one more question. What is the warranty that Markham offers on works like this?
Yeah, that's a great point, and it's something that we are very passionate about, very strong on. We only provide a performance warranty when we get involved in projects. So these are obviously very project specific, and they relate to very measurable items. So typically it's things like the chloride profiles in the concrete, the permeability of the concrete, things that you can actually measure and monitor over the lifetime of the project. Obviously the visual inspections are very important as well as part of that. But yeah, it is. We always offer a warranty that is specific to that project, specific to the condition of the structure and the age. So yeah, it's not just a standalone product with a product warranty. You can comment some more here, Martin, but we do a lot of feedback in this industry of having a supplier of a product and then having an installer and the problems that go along with that.
Yeah, thanks. So it's actually one of the strongest warranties we come across in the industry. Like you said, so we go from manufacturing through to working with the asset owner, the consultants, work out the best product, and then we're a supply and applications company, so guarantee the application. So right through, so you've got no third parties pretty much. So a lot of the industry would just give you a bucket warranty. They guarantee the product suitable with the bucket. We guarantee the product suitable on your structure inside your concrete. I think that probably pretty much covers it. We had some questions there, did we, Venus?
Yeah, well, thank you for taking the time to educate us on those points. We do have some questions that have come through. Okay, the first one is, how much does the treatment cost?
I can take that one. So it varies a lot. It depends, on the condition of the asset, the age of the asset. So the application rates can vary. If it's already got extensive chloride ingress or showing signs of extensive deterioration, we like to make sure we get plenty of product in the concrete. And then preparation costs. We need clean and absorbent concrete. And then we have access. So you've got, whether it's just a straight slab on ground or whether we need to be off a barge underneath it. So nice, clean, absorbent concrete with easy access. We could be around the $20, $25 a square metre through to something we need to prepare and put scaffolding or barge work. We could be up around 50, 60 square metres, but that's something that we would love to sit down with and look at some condition reports and give an indication, project specific.
Okay, thank you for that. Great. Another question I have here is, does the treatment need to be reapplied regularly? Now maybe Brad, do you want to answer that one?
Yeah, thanks, Venus. Good question. So the short answer to that is no, it's a one-time treatment. So once it's applied to concrete, it becomes a permanent part of it. So it penetrates deep in the concrete, as we said, and sets up a hydrogel, which also creates calcium silicate hydrate in the concrete. So this actually becomes part of the concrete and can't be removed from the concrete. So it doesn't need to be reapplied as a maintenance for maintenance on that side of things, but the only time we would reapply it is if things in the structure have changed dramatically, such as you've had to do some maybe adds onto the structure or some different types of concrete repairs to areas, or for some reason a lot of shrinkage cracking or something else has happened to the structure. So typically no, but if there are any questions on that one, we'd normally just come to site and have a look at it.
Okay, cool. All right, I've got another one here. Is there a cost to the client for Markham to look into a project and provide a solution? Maybe Doug, you might want to answer this one.
Yeah, sure thing. So I guess, again, it varies on what the project involves or what the condition of the structure is. If we, if we're doing a very basic, easy, accessible structure that we can, go and have a look without too much in the way of safety documentation or confined spaces, that type of thing, there might be a small charge. We do charge if there is obviously confined spaces, and there might be some other things we want to look at, like Schmidt hammer tests and things like that. There might need to be a bit of cleaning down so we can actually see the concrete itself, like in a water tank or in a sewer treatment tank or something like that. So in those cases there would be. So yeah, it is. I guess it's a sliding scale as to what's involved there. I hope that helps there.
Okay, that's cool. Okay, another one here. Do hydrogels allow you to paint over the top, for example, on line marking?
Yeah, I can probably take that one. Yeah, so we're a two-part warranty, really. We guarantee the efficacy of the product. It's going to work on your project, but also we guarantee compatibility. So we know from what we're adding and the reaction we're causing in concrete that anything formulated to go onto concrete is going to be compatible with Acron treated concrete. So that's any anti-graffiti coatings, line marking, aesthetic paint jobs, anything like that, we guarantee compatibility. So if your product's made to go onto concrete, it can go on Acron treated concrete.
No, that's awesome, thank you. There are no more questions on my list here, so I guess that's about it. Just like to thank you for answering the questions. Thank you for the audience for tuning in, and hopefully we'll see you again soon.
Thank you, Bruce.
Thanks, guys.
Thank you.